Hello and welcome to a video on transformations of exponential functions. Now this assumes that we already have a basic foundation of exponential functions and know that all exponential functions, at least the parent functions, have three key points and a horizontal asymptote. So they all have the point 0, 1. They all have the point 1, a, and a being whatever the base is. And they all have the point negative 1, 1 over a. Again, that a being the base. And they all have a horizontal asymptote at y equals 0. So that's the foundation that we already know. It doesn't matter whether it's growth or decay. These will always be the case for the parent function. So in this first problem, let's identify what is the parent function. And we see a base of 2. So the parent here will be just, let's call it f of x equals 2 to the x. So that means, importantly, a is 2 for this problem. All right, let's take a look at the inner function, the outer function, and then the transformation rule. Okay, so the inner function is whatever is 2 is being raised to, and that's just y equals negative x. That's our inner function. Now we need the inverse of that, and the inverse of y equals negative x is also y equals negative x. So this tells us what's going to happen to the x. The outer function is going to be whatever's happening to the 2. Nothing's being multiplied by the 2, so it's just going to be y minus 3. All right, and so this means our transformation rule, xy, will go to negative x and y minus 3. All right, and we're going to apply the rule to the points that we just wrote up here. So we're going to apply that to 0, 1. We're going to apply it to 1a, and again, this time a is 2, so 1, 2. We're going to apply it to negative 1, 1 over 2. And then last, we're going to apply it to the asymptote y equals 0. All right, so if we plug in a 0 and take the opposite here, we still have 0. Nothing happens to that point. And 1 minus 3 is negative 2. So we're going to plot that 0, negative 2. May as well plot it right now. All right, we've got 1, 2. The opposite of 1 is negative 1. And 2 minus 3 is negative 1. So we're going to plot the point negative 1 right there. All right, and then we've got negative 1, 1/2. So the opposite of negative 1 is positive 1. And 1/2 minus 3 is negative 2.5. So we'll plot that point 1, negative 2.5 right about there. And we've got this asymptote that's just the y. So what happens to y is we subtract 3. So it's going to be 0 minus 3 or negative 3. So we've got this horizontal asymptote at negative 3. And so we can see the curve is going something like this. And it ends up, a couple things to point out about this curve. Okay, first of all, we don't have to write the points since they're already right here. We don't need to write them again. One thing you might notice is that there's an x-intercept, and we don't really know what that intercept is, so that's going to come a little bit later. That's going to come in the next class when we can take the graphs, one more detail of the graphs to figure out what that x-intercept is. But for now, we're just going to put a little question mark. And if those of you have studied logs and you're thinking ahead a little bit, we're going to use logs to find those y-intercepts. The inverse of the exponential is the logs, and we're going to use those, but not today. The other thing I wanted to point out on here is that this has a base of 2. And shouldn't that be growth? Well, not really, because it has an exponent of negative x. So 2 to the negative x is like 2 to the negative 1 to the x, right? That's really 1/2 to the x. So what we really graphed here, and we could have done this in a completely different way had we thought that way before starting the problem, we could have graphed a decay function that just moves down 3 units, right? And that's what we're looking at, right? The point that was normally 1, 1 moved down, everything moved down from an exponential decay. All right, let's look at the next example. So this time we've got our parent function would be f of x equals 1/3 to the x. There's our parent function. Let's change colors here. And so a is 1/3. That's going to definitely be important. All right, now our inner function is y equals x minus 1. That's what the exponent is. That's where the x goes. So y equals x minus 1. Now we're doing this using transformation rules, so we're not really thinking we're going to move the function over, although of course we are going to move it over. We're going to move it to the right. What's going to happen to the inverse of this? Well, we're going to switch x and y. And then we're going to solve for y. So y equals x plus 1. So that's what's going to happen to our x's. And what's our outer function here? Our outer function is 2 is being multiplied by the base, so there's going to be a 2y and plus 3. Everything else is either based on the parent or the exponent, which makes it the inner function. So our xy goes to x plus 1, 2y plus 3. And our key points, 0, 1, 1a, and this time a is 1/3, so 1, 1/3, and negative 1, negative 1/3, which is 3. Negative 1, 1 over 1/3, which is 3. And then our horizontal asymptote of y equals 0, we'll see what happens to that. All right, so 0, 1, we have 0 plus 1, which is 1. 1 into the 2y plus 3 becomes 2 plus 3, or 5. All right, 1, 1/3, 1 plus 1 is 2. 2y plus 3 would be 2 times 1/3 plus 3. That's 3 2/3. Let's just write it as that, 3 2/3. And then negative 1, 3. Negative 1 plus 1 is 0. And if we do 2 times 3 plus 3, we get all the way up to 6 plus 3 is 9. So we're going to be a little bit off the chart on this one, but we'll figure it out. All right, and then we have the horizontal asymptote. If we plug in that into the y part, because it's a y equation, we're going to just get y equals 3. 2 times 0 is 0, plus 3 is 3. So y equals 3. Let's go ahead and plot that asymptote. Let's plot our points. Looks like everything is going to be above that. So I think what I'm going to do is I'm going to extend my axis a little bit. Put a few more tick marks on here. Not a perfect world, but I think that'll work. And we have the point 0, 9. I'm just going to go backwards on the intercept here. So 0, 3, 4, 5, 6, 7, 8, 9 right there. We have 2 and then 3 2/3. So 2 and then 3 2/3 is like right about there. And then we have 1, 5. At least it's on the right track. So 3, 4, 5 right about there. And that gives us an idea of the shape of the curve. Remember that it is being stretched, so it's a little bit harder to graph when it's being stretched, but we can see the path that it's taking. So it's going to go up this way. It's going to come this way. And this time, we wouldn't have to take a log because there is no x-intercept. If I was going by what I said before, that we're going to use logs to find x-intercepts. All right, let's look at our last example. This one is a natural base of e. So let's start out by observing that. So our parent function, f of x, is e to the x. And that means that the base a is the number e, or approximately 2.7. The inner function here, y equals x minus 3. Switch x and y. Solve for y, and y equals x plus 3. So that's going to be what happens to the x's. Our outer function is just negative y. So I forgot to put inner here. And the outer is just negative y. So our transformation rule, xy, will go to x minus 3, negative y. Okay, that's actually x plus 3. All right, so we're going to apply that to the points 0, 1. 1a, in this case a is e, so 1e. Negative 1, 1 over e. And then there's also this horizontal asymptote at y equals 0. All right, so let's see what happens. So 0, 1 goes to 3, negative 1. 1e goes to 4, negative e. And negative 1 over e will go to 2, negative 1 over e. And let's just keep in mind that e is about 2.7 and 1 over e is about, for purposes of what we're doing, it's 3.7, I think, but it's 0.37. I mean, we're going to call it 0.4 for our purposes of estimating this on a graph. All right, so let's see. Oh, and the horizontal asymptote is still going to be at 0 because negative 0 is still 0. There's no such thing. So the horizontal asymptote will still be y equals 0. Let's go ahead and plot that first. So we've got our horizontal asymptote. Let's plot our points. So we've got 3, negative 1, 1, 2, 3, negative 1, right about there. We've got 4, negative e, that's about 2.7. So 4, negative 1, 2.7, maybe right about there. And then we've got 2, and then like 0.4. So 2 is somewhere around here, 0.4. And we've got this going asymptotically towards that intercept. It's going to have a y-intercept. It's not going to have an x-intercept. We can figure out what the y-intercept is without too much trouble, because if just for the y-intercept, we can just plug in 0 for x. So we'd have f of 0 equals negative e to the 0 minus 3, or in other words, negative e to the negative 3. And we can just plug into our calculator, because when we go to our calculator, we're going to, to find the e button, I can just push the negative and then the e to the, and then it's going to go to the negative 3. So negative 3, and I'm looking at negative 0.05. Well, it's pretty small. So it's approximately negative 0.05. Pretty much hard to estimate that on the graph like this, but that's what it is. So this point right here is 0, negative 0.05. That's rounding to the nearest hundredth. Okay, but there's the general shape of that exponential. It turns out to be decay because it's got actually, I'm not going to call that decay. I'm going to call that just the reflection of a growth curve. So it is it's decreasing because it's a reflection because of this right here. It's a constantly decreasing function, being the reflection over the y-axis, the x-axis of a constantly increasing function. Okay, so this is just one way to graph. You can also graph these. We could have easily graphed this one without the method that we use by just saying this is moved to the right 3 units and it's reflected vertically, and then that's exactly what we're looking at here. So we could have done it that way. Just chose to do these 3 examples as transformation rules because, as you know, transformation rules are a nice universal method that work for all problems. Okay, I hope you found this helpful.